So, good afternoon, everyone. I think we are at the end of this entire syllabus, which is required for your physics examination. We are almost done with all VSEQs, and we are left with only one chapter, that is ray optics. Once we are done with ray optics, I will be discussing few very important questions from ray optics. Once we are done with ray optics, then we'll move on to the numericals of nuclei. By that, we'll finish all the things, that is around 60 marks, entire physics papers of second year. So today we are going to discuss the last topic, that is ray optics. Ray optics. See here. Few questions we have already discussed in ray optics. What are those questions? We have discussed regarding Cartesian sign convention. Then we have discussed regarding what is the focal length, and then we have obtained the relation between focal length and radius of curvature. Then I said that we'll be having two types of mirror, that is called as concave mirror and convex mirror. Similarly, we have two types of lenses we'll be discussing regarding convex lens and concave lens. After that, we have discussed regarding critical angle, total internal reflection. All those things were discussed by me. So now we are going to discuss important VSEQs from this chapter. So please note down the first VSEQ from this chapter, that is first VSEQ. Define focal length and radius of curvature of a concave lens. So he is asking you to define what is focal length and radius of curvature of a concave lens. So I hope you know the concave lens is something like this. This is the symbolic representation of concave lens. This point is called as optical center, and from this point we'll be having of curvature, and we know that in between center of curvature and optical center there will be what? There will be a focus. So you can define focal length as distance between optic center and focus of a concave lens. So what is the definition for focal length? I can define focal length as what? The distance between optical center and principal focus is called as what? Focal length. Similarly, what he is asking you to define radius of curvature. See here, this is center of curvature. Distance from center to this particular point pole or optical center is called as what? Radius of curvature. So how you can define radius of curvature? Distance between optic center and center of curvature is called as what? Is called as radius of curvature. So this is another important question from this The first important question from this chapter, what is that? Define focal length and radius of curvature of concave lens. So what is the definition for focal length? The distance between focus and optical center of a concave lens is called as what? Focal length. And the distance between optical center and center of curvature is called as what? It is called as radius of curvature. Let us move on to the next question. Next important question from this chapter. That is, second one, define power of a focal length. Define power of a convex lens, full stop. What is its units? What is its units? So very easy answer. I hope everyone know. Power of a convex lens is given as P is equals to 1 by F. P is equals to 1 by F. So how you can define power? Power is equal to, what is that? Power is equals to reciprocal of what does F represent? F represents focal length. Focal length. In many books, you will be finding some different types of definitions. But if you are writing this definition, it is also more than sufficient, because this is a very small answer type question. So how you can define power of a convex lens? Power of a convex lens is equals to what? Reciprocal of focal length. And what will be the unit of power? Unit of power is given as dioptric. It is represented by D symbol. So this is the end of the next question. So what was the question? Define power of a convex lens and what is its unit. So how you can define power? Power is equals to what? Reciprocal of focal length, and the unit is D. Let us discuss the next important question from this chapter, that is, what is dispersion? Which color gets relatively more dispersed? Relatively more dispersed. So this is the next important question from ray optics. What is the first thing he is asking? He is asking you to define dispersion. So what is the meaning of dispersion? I hope you might have studied the concept of prism. If I consider a prism and if I make a light to incident on it, a white light to incident on it, then what will happen? This white light will get divided into 7 colors. This white light get dispersed into how many colors? 7 colors. Finally, the colors will come out something like this. This is red color. This is violet color. Here, the deviation of red color, I am representing it with delta R, and the deviation of violet color, I am representing with delta V. So, whose deviation is more? Violet color deviation is more when compared to the red color deviation. So, how you can define a dispersion? How you can define the dispersion? Dispersion is nothing but whenever a white light is passed through a prism, the white light gets dispersed into how many colors? The white light gets divided into 7 colors. What are the 7 colors? The 7 colors are violet, indigo, blue, green, yellow, orange, and red. So these are the 7 colors. Whenever a white light is passed through prism, what will happen? The white light gets divided into how many colors? 7 colors. And which color will get dispersed more? Violet color will get dispersed more when compared to red color. So what is the definition you can write? You can write, when a white light When a white light passes through a prism, no need of drawing the diagram, passes through a prism, what will happen? It gets split up into how many colors? 7 colors into its constituent colors. Constituent colors. So what are those constituent colors? That is nothing but Vibgyor. So this phenomena is called as what? Dispersion. And which color will get more dispersed? Violet. Violet color gets more dispersed. Violet color will get more dispersed. So this was the next important question from this chapter. What is that? What is dispersion and which color gets relatively more dispersed? So the next important question from this chapter is, what is myopia? Fourth one. What is myopia? I hope everyone know what is myopia. Myopia is also called as what? Nearsightedness. Answer. What will happen for a myopic person? Whether he will be able to see the near things clearly? Yes, he will be able to see the near things clearly. But what about the things which are far away? The far away things won't appear clearly. Isn't it? That is the reason it is called as what? Short-sightedness. Now, where will be the image form? Image will form in front of the retina. So you can write, what is myopia? It is also called as what? Short-sightedness. So, it is a defect of human eye. It is a defect of human eye in which light from distant object is converged to a point in front of retina. So how we can correct this myopia? Myopia can be corrected using concave lens. Eye, let us assume this is our eye. So what will happen? The light ray will converge in front of retina. This is our retina. What? This is our retina. So instead of converging on retina, the light is what is happening? The light is converging before the retina. So in order to correct this, what we'll be using? In order to correct this, we use which type of lens? Concave lens. We use which type of lens? We will be using concave lens. So see here, what will happen if I draw a concave lens in between eye and ray? This is concave lens. The light rays are coming parallelly, something like this. Here I am having my eye. Now what will happen? The light ray will somewhat diverge, something like this here. Again, all of them will converge on retina. So they will converge on what? Retina. I hope you understood this. What is myopia? Myopia is a defect of human eye in which a light coming parallel will converge where? In front of the retina. In order to correct this, which type of lens we'll be using? We will be using concave lens. We'll be using what? Concave lens. So let us discuss the next important question. So this is next one is question number 5. Question number 5. Next will be myopia is done. Next will be hypermetropia. Next will be what? What is hypermetropia? What is hypermetropia? So in this defect, what will happen? If this is my eye, the light rays will come something like this. Now, once the light ray enters my eye, they will converge behind the retina. They will converge where? Behind the retina. So how you can write? In this defect, what will happen? Light from an object, converge behind the retina. So how you can correct this then? For correcting myopia, we have used concave lens. For correcting myopia, we have used concave lens. For correcting hypermetropia, we will be using which type of lens? We will be using convex lens. Which type of lens will be using? We'll be using convex lens. If this is our eye, then what will happen? Convex lens will convert the rays. Light will form on the retina. So I hope you understood this. So which type of lens? To correct this, we use convex lens. To correct this, which type of lens we'll be using? We'll be using convex lens. So these are the most important questions from this particular topic. We'll be discussing one numerical which may be asked in the examination, that is 6th one. The numerical is a small angled prism. A small angled prism of 4 degrees deviates a ray through 2.48 degrees. 2.48 degrees. Find the refractive index of the prism. Find the refractive index of the prism. Find the refractive index of the prism. So here, mu minus 1 into A. This is the formula for thin prism. And what we are supposed to find? We are supposed to find the value of mu. What is the value of deviation given? It is 2.48 is equals to mu minus 1 into what is the angle of prism? 4 degrees. This is what? 4 degrees. So what this will become? 2.48 divided by 4 is equals to mu minus 1. So if you solve this, you will be getting mu is equals to 1 plus 2.48 divided by 4. So this will become how much? 1 plus 4, 6 are 24. So here point is there. So this will become 0.62. This will become what? 0.62. So the refractive index of prism is how much? Mu is equals to 1.62. So this does not have any units because it is a constant for a particular material. So refractive index of a prism is how much? It is mu is equals to 1.62. So this is an important question from this ray optics. So by this, we finish in the entire syllabus required for scoring 60 of 60 in second year physics. So now we are going to discuss few important problems from nuclei chapter. Important numerical for long answer type questions. Important numerical for what? Long answer type questions. So see here, we will be discussing first regarding nuclear physics. Nuclear. First problem. They will be asking the questions based on half-life time. So let us do the problem based on nuclear physics. See here. First problem. The half-life of radium is 1600 years. 1600 years, full stop. How much time does 1 gram of radium takes to reduce to 0.125 grams. Takes to reduce to how many grams? 0.125 grams. So see here, as these are 2 marks answer, if you are able to write just what? If you are able to write just the formula and final answer, that would be more than sufficient. So what is the formula? Everyone should remember the formula. The formula is N divided by N naught is equals to 1 by 2 whole power N. This is the formula you should remember. N divided by N naught is equals to 1 by 2 power N, where N is equals to T divided by half lifetime, T half, T divided by T half. Let us substitute the values here. See here. Initial N naught is how much? 1 gram. After some time it has become how much? 0.125 grams. So I can write this one as 0.125 divided by 1 is equals to 1 by 2 power N. That is nothing but this can be written as 0.125 can be written as what? 125 divided by 1000 is equals to 1 by 2 power N. So this will become 125. So I think it will, if I divide this, how much? 1000 divided by 125. 1000 divided by 125. It will become 8. So 8 now. So from here I can write 1 by 8 is equals to 1 by 2 power N. This 1 by 8 can be written as what? This 1 by 8 can be written as 1 by 2 power 3 because 2 cube is 8. So from here we are getting one value. The value of N is how much? 3. The value of N is how much? 3. Half-life of radium is given. How much is the half-life of radium? 1600 years. So what is the formula for N? N is equals to T by T half. N is equals to what? T divided by T half. So from here I can write what is the value of N we got? 3 is equal to what is the value of T? 1600 divided by T half. So what will be the value of T half? Sorry, we are supposed to find the value of T now. Okay. Half-life time is given. Okay. Half-life time is given and we are supposed to find the value of T. So T divided by, what is the half-life time given? 1600 years. So this will become T is equals to 1600 into 3 will become how much? It will become 4800 years. Now see here, as this question will be asked for 2 marks, if you are able to remember this formula and if you are able to remember this answer, it is sufficient. If you don't remember these points, no need, don't worry. If you are able to remember this formula and if you are able to remember this answer, that's enough. So whenever you are getting here 1600, remember the answer will be 4800 years. So this is one of the important questions for LAQ from nuclear physics. Let us discuss the next question. Next important question, that is plutonium decays with a half-life of 24,000 years. 24,000 years. Full stop. If it is stored for 72,000 years, if it is stored for 72,000 years, what fraction of it remains? What fraction of it remains? He is asking the value of n by n naught. He is asking the value of what? N by n naught. Again, you are supposed to write what? You are supposed to write down the formula. What is the formula? I know that the formula is given as, because if you write the formula, you will be getting 1 mark. N by n naught is equals to 1 by 2 power n. N by n naught is equals to 1 by 2 power n. And what is the value of n? N is equals to small t divided by t 1 by 2. So we know the value of half-life time. What is the value of half-life time? Half-life is given 24,000 years. And total life t is how much given? 72,000 years. Let us substitute the value, find the value of t. So what this will become? What is the value of t? 72,000. And what is the value of half-life time? It is 24,000. This 3 zeros and this 3 zeros will get cancelled. 24 ones and 24 3. So what is the value of n we are getting? 3. So if I substitute this value, what this will become? N by n naught is equals to 1 by 2 power 3. That is nothing but 1 by 8. So if you are able to remember this formula and if you are able to remember this answer, then it would be sufficient for you. So we are done with 2 most important problems. So one more problem is left, I think. Yes, one more problem is left. So 1 or 2 more problems are left, which are very important as far as examination is considered. What is that problem means? Third problem, very important problem. If 1 microgram of 92 uranium 235 is completely destroyed in an atom bomb, comma, how much energy is released? How much energy is released? So this is based on the formula E is equals to mc square. Energy is, what is the formula? E is equals to mc square. This is based on this only. So mass is given. What is the mass given? Mass is 1 microgram. 1 microgram means how many grams? 1 into 10 power minus 6 grams. If I convert this grams to kg, how much this will become? 1 into 10 power minus 6. 10 power minus 6. And 1 gram is equals to how many kgs? 10 power minus 3 kgs. 10 power minus 3 kgs. So how much this will become? This will become 10 power minus 9 kg. So just substitution the value. What is that? E is equals to mass. How much mass we are getting? 10 power minus 9. And what is the value of C? I hope everyone know the value of C. 3 into 10 power 8 whole square. So what this will become? 10 power minus 9 into 3 square will become 9. And 10 power 8 into square will become how much? 16. So this will become how much? 9 into 10 power 16 minus 9. So what will be left with? Energy released in this will be 9 into 10 power 7 joules. 9 into 10 power 7 joules. So here also, if you are able to remember this formula, and somehow if you are able to remember this answer, then it would be sufficient for you. So one more question is left. If you are done with that question, then we'll be done with the numericals of nuclear physics. Important numericals for nuclear physics for LAQ. Fourth question. The question is, calculate the energy equivalent of 1 gram of substance. Again, you are supposed to write the same formula. What is the formula for energy? The formula for energy is given as E is equals to mc square. And mass, how much mass is given? Mass given is m is equals to 1 gram. If I convert this into kg, how much this will become? 10 power minus 3 kg. So if I substitute that value, what I will be getting? 10 power minus 3 into c square. C square is nothing but 3 into 10 power 8 whole square. So how much this will become? 10 power minus 3 into 9 into 10 power 8 to the how much? 16. So this will become how much? 9 into 10 power 16 minus 3 will become 13 joules. So by this, we finish all the important numerical from nuclei physics chapter or nuclei chapter. So from this, you can expect one numerical along with LAQ in annual examination. So tomorrow we'll be discussing the numericals based on current electricity. There are around 5 to 6 numerical based on current electricity. Tomorrow we are going to discuss those numericals, or today I will discuss one or two numericals from this current electricity, and remaining we'll discuss tomorrow. Otherwise, let us see if time permits. So let us see, let us do one or two problems from current electricity for LAQs only. Now we are discussing regarding LAQs only. Current electricity numericals. For what? For LAQs. See here, first LAQ from current electricity is telling that in a potentiometer, a cell of EMF, 1.25 volts, gives balancing point at 35 centimeter length of the wire. 35 centimeter length of the wire. Full stop. If the cell is replaced by another cell, if the cell is replaced by another cell, and balancing point shift to 63 centimeter. What is the EMF of second cell? What is the EMF of second cell? So this is the question. Again, very easy question for LAQ. What is the formula? We know that the formula for potentiometer, because we have already did the LAQ. E1 by E2 is equals to L1 by L2. So we are supposed to determine the value of what? We are supposed to determine the value of E2. E2 will be equals to what? L2 divided by L1 into E1. So what is the value of L2? The value of L2 is 63 centimeter. And what is the value of L1? The value of L1 is 35 centimeter. 35 centimeter. And what is the EMF one? It is 1.25 volts. So if you solve this, you will be getting the answer as 2.25 volts. If you solve this, you will be getting the value of E2 as how much? 2.25 volts. So let us finish today's class here itself. We'll meet tomorrow with the other important problems from current electricity. I hope you all are revising the things. Please do read the two important chapters for LAQ, that is nuclear and current electricity. And as far as SAQs are concerned, please go through the chapters of electric charges, electric potential, then wave optics, ray optics, semiconductor devices, electromagnetic induction, because we have discussed 8 chapters, and out of 8 chapters, you will be getting 8 SAQs, but you are supposed to write only 6 SAQs. So please be perfect with any 6 chapters. Then we have discussed regarding VSAQs. In VSAQs, we have discussed all the 10 VSAQs from where they can ask the question. So if you are perfect with magnetism and matter, dual nature of radiation and matter, and communication system, then definitely you will be able to, if you are perfect with 3 chapters, then definitely you will be able to write down the 5 VSAQs. So I hope you understood today's class. We'll meet tomorrow. Thank you.